Hey guys, my name is Talia. I'm a staff member at Discovery and I'm going to help you do your homework today. So, back in the day of the Vietnam War, the United States started a draft for people to enter military service. Basically, everybody was assigned, every man of the correct age was assigned a number, and then those numbers were called in order to see when that person would have had to serve their mandatory time in the military. And we have information about this. We have information about the day somebody was born, or their birthday, and then we have information about their lottery number. And this question is a 5-part question. There are 5 separate questions and 3 sets of plots that we're looking at to answer those questions. And there's points distributed on these plots, and we want to use these points to kind of deduce things about the correlation, see what kind of relationships we're finding, differences, similarities, stuff like that. This is really testing your ability to understand correlation from a plot, and that's something that's pretty important in data science. So let's get started with the first one. So this first one here, we have 2 different plots. Basically, the x-axis of this one, this is for the year 1969, of all the draft numbers that were assigned. This is the day of the year, 1 through 365 days, and then the y-axis is the draft number that was assigned to that person on that birthday. And then this is the same thing for 1970, just 1 year later, all the days of the year the person was born, and then the draft number that they were assigned. And our task here is to just select one of these questions that tells us, what can we say about the correlation of these 2 plots? And your options are one of the plots stronger than the other? Are they close to -1, +1, or 0? And initially, just based on the way these points are distributed, we can say that these 2 can be ruled out because they look pretty similar. There's not really a difference in relationship between the 2 variables on either of the plots. They're both big blobs, right? So we can't really say that 1970 is stronger than 1969 or vice versa. So let's eliminate those. And now we're tasked with now that we know they're both similar, what can we equate them as? What can we guess about their correlations? And generally there isn't really correlation here. You can't really draw a nice line. You can't see the direction they're going. If you wanted to, it would probably just be a straight horizontal line. And so some people might be tempted to answer that they're both near -1 here because people associate negative numbers with bad correlation, weak correlation, and positive numbers with good, strong correlation. But that's not really how it works here. In this case, -1, if you have exactly -1 correlation, you have really strong correlation, it's just negative, right? So if you have negative correlation, it means as one variable goes up, the other one goes down. And if you have strong positive correlation, as one goes up, the other one goes up too. And then if you don't have any correlation, it's close to 0. Think of it in terms of absolute value. If the absolute value is close to 1, these both have absolute value close to 1, it's good. And if it's close to 0, if it doesn't really have a good absolute value, then there's no correlation there. And that's kind of reflected here. You can see the slope of this line that would kind of go through the points is 0, right? So in this case, it would be this one. They both have correlation near 0. There's not really a relationship here at all. So we figured that out, right? We know that there's not good correlation. Can't really say anything about your draft number based on the date you were born. So let's just focus in on 1 year and see if we can find some relationship somewhere else. So these 2 plots are both using information from 1969. This is the same one that was over there, where it's the day of the year versus the draft number. But here, we average the draft numbers by month of the year. So this is the average draft number for every month, and the points are plotted here. And now we're tasked with another comparison question. Which plot has stronger correlation? Neither is stronger, they're both pretty much the same. This one, the days plot, has stronger correlation, or this one, the month plot, has stronger correlation. You have to pick one. And in this case, I think it's fairly clear that the plot with months has stronger correlation. Because like we said back there, this one has correlation near 0. There's not really a relationship here. This one, you can see a line taking shape. You can see that as month moves on, the average draft number decreases. You can see that you can kind of draw a line here, and it looks pretty good. The points fit around the line pretty well. And there's but there seems to be a relationship here based on the way the points are distributed across the graph. So we can say that months has a stronger correlation. And like I was saying before, this would be an instance of negative correlation, right? So this would be, a negative number. and this would have an absolute value close to 0. So now that we know that there's a better correlation between averaging the draft numbers and month, we're gonna go back to comparing both years and compare this plot with a similar plot for the year 1970. And there are 3 questions to answer about that one. That's kind of like finalizing our analysis. So this is the one that we saw back there, month of the year, then having the draft number. I made the points thicker so they were easier to see. Sorry if they were kind of weak on the last one, but you get the idea. And then this is the same plot for 1970, the average, the number, the draft number for every month. And so the first question asked here, this is more of like guessing, this is more guessing like the number of the correlation, the strength of the relationship based on what the plot looks like. So it's asking you to match one of these correlation coefficients to this plot, this 1969 plot. So in this case, we can eliminate 1 and -1 because this is not, well, this is like a pretty good correlation. We can clearly see a relationship here and you can see a line here. It's not perfect. A perfect correlation would literally be like, these points are exactly in a straight line. There is nothing missing between them. That's not what we have here. And then -1, this is -1, +1 would be this way, a perfect line this way, because it's like slope. Anyway, so we can eliminate 1 and -1. And then it wouldn't be 0.01, because this is basically 0. And that would be more like those plots over there where it was like a big scramble where there's no relationship, because this is really close to 0. There's a very low absolute value. So what's left is -0.87, and this makes sense because we said this is a strong negative correlation. As month goes up, the average number goes down. And this is actually, I didn't say this back there, but this is an indication of unfairness in the draft picks because your average draft number should not differ based on what month you were born in. This is basically saying that like people who are born in certain months are more likely to be picked earlier because the draft numbers are picked in order, right? So that's potential unfairness, and this was a huge point of criticism in the 1969 draft, which is the idea of a draft is already unpopular among certain people anyway. So this is a quantitative representation of that. That's pretty cool. Anyway, so we can say -0.87 is good because that's pretty close to -1. We have a pretty good negative relationship here that represents the way our points are distributed. Our next question is very similar. Match a correlation to the 1970 plot. And this one is a little more jumbled. You don't really see a clear line here as much. It's pretty weak. So we can definitely eliminate -1 and 1 for the same reasons as before. It's definitely not -0.87 because it's not as strongly correlated as the 1969 plot, right? So let's eliminate that as well, and what's left is 0.01, almost no correlation. And this makes sense because, again, there's not really, this is like the plots before, there's not really a relationship here. They're not like really moving and in accordance with each other. And if you were to draw a line, it would maybe be like a really, really weak horizontal slope, like a 0.01 value. Like it's very weak. So that's what we would pick for this one. And the final question, what can we conclude from all this, right? Because after this happened, people were upset and they really wanted the draft to be more fair the next time around. And so in 1970, they tried to fix it. Did they fix it? That's what the question asks. Was the 1970 draft more random than the 1969 draft? Was the 1969 draft more random than the 1970 draft and the situation actually got worse? Or are they equally random and there was no change in the situation? I would say based on these numbers that we selected and based on the way the points are distributed, that 1970 is more random than 1969. Because again, here there's a relationship, here there's not really a relationship. This is what we want for fairness, and there's pretty obviously a change, so it's definitely not this one. They're not equally random. And 1970, there's not really a relationship, it's more random. So that's the final question. I hope this was really helpful in teaching you how to visualize correlation based on the way points are distributed on a graph, because sometimes it's cool to look at our formula for correlation coefficient and then see how it applies on actual data like this. So I hope this is helpful.